Welcome to my channel EasyML. In the previous video, we were looking at standard deviation. Another way to measure dispersion or variability in the data is interquartile range. What is the interquartile range? The interquartile range, or the IQR, is another measure of variability based on dividing datasets into quartiles. Let us now explore and see what we mean by quartiles. Again, coming back to the sample data where we had one underperforming student that is highlighted in red, we first ensure that we arrange the marks obtained by these students in ascending order, which I have done here. We then single out the following values: the minimum value, which is naturally 5%, the median value, which, as I explained previously, is the central value. In this case, that central value happens to be 64.5, and the maximum value, which is 92%. Since the median is bang in center, we can safely say that it has divided the dataset into two halves, that is 50% on the left hand side and 50% on the right hand side. Now let us focus on the 50% of the data that is towards the left of the median. We have 4 values to the left of the median. We now take the central value in the data that lies towards the left of the median. This central value lies in between values 2 and 3, which is a 52 and 53 as highlighted here, and the value in between is reported to be 52.5. Now let us call this value 52.5 as quartile 1 or Q1. If you observe carefully, the quartile 1 lies in between the minimum value and the median. And naturally, since the median value is dividing the data into 50-50, it means that the quartile 1 has further divided the data set on the left hand side into 25-25. That is 25% on each side. It is important to note that the median is quartile 2. Now, let us go to the other side, or the other 50% of the data that lies towards the right of the median. We again have 4 values that lie towards the right of the median. We do the same exercise here and obtain the central value. This central value happens to be 86 in this case, and now we call this value as quartile 3 or Q3. Hence, again we see that quartile 3 lies in between the median and the maximum value, so quartile 3 has divided the right hand side data set further into 25-25, that is 25% on each side. Now we finally have 5 numbers, namely the minimum value, quartile 1, quartile 2, which is essentially the median, quartile 3, and the maximum value. Where if you observe carefully, the width between these 5 values is 25, hence the term quartiles. Now, since we have calculated all the quartiles, the interquartile range, or the IQR, is nothing but the values between Q1 to Q3. So the variation or the variability in this particular data set is deemed to be between 52.5 and 86, where 52.5 is the lower limit and 86 is the upper limit. Now, if we observe carefully, let me just go to the previous slide. Given the same data set with the underperforming student, when we calculated the variability using the standard deviation method, the variability was as high as, it was somewhere between 34.8 to 90.8. This range is wider due to the student who has scored 5%. Now coming back to the current slide. So here, if you observe carefully, the interquartile range has calculated the variability or dispersion in the data by weeding out the effect of that particular outlier. So when we summarize this data set now, we do so by saying that the class performance is 64.5%, which is the median value, where the marks scored or the marks obtained by the students could vary between 52.5%, which is quartile 1, to 86%, which is quartile 3. Since now we know all about central tendencies and various measures of variability, let us go through a quick recap of data summarization in the next video. Stay tuned.